Okay, so similar solids and Cavalieri's principle is our last little chunk. So go ahead and write your name on it. Last geometry thing. Yes. So when I was saying about constructions are using like previous knowledge and like circle information. Do you know how to use a protractor? Have you ever seen, is it a protractor or is it a compass? I think it's a protractor. Where you swivel. No, that's a compass. I'm getting my geometry things mixed up. Where you swivel and you draw little arcs. So that's our last little chunk. And then we're reviewing for the EOC. May 9th. Okay, similar solids have exactly the same blank, but not the same blank. What do you think? What do you think? Exactly the same what, but not the same what. Remember back to similar figures? They had the same blank, but not the same blank. They will not have the same volume, meaning they do not have the same, starts with an S. Both these words start with an S. They do not have the same size, but what do they have the same? What are these? They're the same shape. Yeah. Once you guys knew it, you're like, no, it's shape. We know it's shape. Okay. Two solids are similar if the blank of their corresponding blank are blank. Lots of blanks. What do you guys think? It's an R word. Does that help? Yes. Remember that similarity? We have ratios. Two solids are similar if the ratios of their corresponding lengths or linear measurements. So I'm going to say linear measurements, but we're going to talk about that. Because that's a weird way to say lengths, are congruent. I think that's the word my first period said. So, meaning that their ratios are the same. Not necessarily congruent, I would say, are the same. So when I talk about linear measurements, I'm talking about lengths. And there's one more. What if we added up all the lengths? That would be the perimeter. What about if it's not a polygon? What if it was like a cylinder? What would it have? It wouldn't have a perimeter. It would have a circumference. Beautiful. Okay, so two solids are similar if the ratios of their corresponding linear measurements, meaning lengths, perimeter, or circumference, are congruent, meaning the ratios are the same. Let's go ahead and determine whether the solids are similar, and if so, give the scale factor in simplest form, meaning you reduce it. Okay, let's look at the let's pick some of the measurements. What measurement do you want to compare in these two? Do you want to compare the heights, 3 and 12? 12 to 3. What is that? Reduce it by 3? 4 to 1. We got to compare one more thing, otherwise it's not enough information. I think that might be my scale factor. Do you want to compare the perimeter, or do you want to just compare one of length? 8 to 2, and then we'd have to talk about 20 to 5. Do they both have a scale factor of 4 to 1? Yeah, so I don't even have to look at it to know that 8 to 2 is 4 to 1. And so is 20 to 5. That's also 4 to 1. Everyone's seeing how we got that? Question mark. we're reducing by, in the first case, 2, or in the second case, 2, and in the third case, we're reducing it by 5. So yes, they are similar. All of those have the same measurement. Let's take a look at number 3. What do you think for that one? You can compare 30 to 25, and then we want one more. I like how you said 24 and 20. You realize that 10 was the radius and not 20. So, very nice catch. Okay, let's reduce. What can you reduce 30 and 25 by? Yeah. And then 24 and 20. 4? Question mark? Does it get you the same thing? Yeah, okay, very nice. So these both were. I skipped 2 because I figured you guys could for sure do that one on your own. You want to try it? Okay. Go ahead and pick 2 links that are different and see what you get. You're picking 2 links and comparing it. I'm assuming that it's a square, and it's not a big assumption because of what information that they give me. Yeah, the length and the width of the base are the same, and they have what else? They have the 90 angles. They have the right angles, yeah. So I just went ahead and found the perimeter. Are you guys okay with what I did? What can you reduce 8 and 12 by? I did the heights and I did the perimeters. 4 again. I can't think of anything else that would go into 24 and 40 other than 4. Oh, 8. Much better. Okay, I figured there was another number. What's 24 divided by 8? 3. And that is 5. Did I do that right? Okay, so what do you think for number 2? They're not equal, so this is no, not similar.
Wait, is there such as to combine the similar ones? Or the same answer?
You mean the perimeter, like I did that? You don't need to. Just if you do that, you have to make sure that you're comparing the right sides. I think you, like how I did this one, I did both 8 and 2 and 20 and 5 instead of doing the perimeter. I think I'm just a little picky about that. But you got the same thing, so I don't think it matters if you do the lengths or the perimeter. Okay, if 2 solids are similar with the scale factor of blank, then their volumes and surface areas ratios are as followed. Okay, that kind of confused me. I stumbled on the words. So basically, if I know the scale factor of their lengths is A to B, okay, so that stands for number to number. So like for number 3, it was 6 to 5. Then what do you think you would do with A and B to get the surface area ratio and the volume ratio? Think about what we do for area and volume. Think about their units in particular. What do you think the surface area ratio would be? What are the units for area always? Squared. We're going to do that same thing to A and B. So it's going to be A squared to B squared. Now, as followed, volume is the same thing. Volume is always what? Units cubed. So A cubed to B cubed. Here we got to be careful with our calculator, okay? So keep that in mind. Let's go ahead and do a couple examples. Identify the scale factor / ratios for each pair of similar solids. So they give me the fact that they're similar, okay? What would be the scale factor for number 4? Yeah, what would be the scale factor? 2 to 1. How did you determine that?
I saw that they were all one.
You looked at the corresponding parts? That's what I did as well. So I saw 6 to 3, 14 to 7, 10 to 5. Yep, I looked at the corresponding parts and did the same thing. So that means we take the scale factor and we do what to get the ratio of the surface area? You square it. So what's 2 squared and what's 1 squared? 4 to 1. And then volume, you would do what? Cube it. So 2 cubed to 1 cubed. 8 to 1. Very nice. Okay, for number 5, we know that they're similar, so you don't have to use the ones that are decimals. We can use the other ones. So how would I write the scale factor using their radii? Yeah, you can either say 3 to 2 or 2 to 3. I'm going to assume that we are going from the first figure to the second figure. So that's why I do it like this instead of how Joey said. Scale factor for the ratio for the surface area would be, nope. 3 times 3? Yep. And then multiply 4 by 2 again and multiply 9 by 3. We're just multiplying one more. So 2 cubed, 3 cubed. What's that get you? 8 to 27. Questions on this? No? Okay, cool. Go ahead and flip it over. I think we've got, yes, last bit. This is how I normally ask you the questions. So normally I give you one piece of information, either the surface area, the volume, or the perimeter. Typically I'll give you perimeter. I'll tell you that they're similar, and I'll ask you to find the other ratio. So for the first one, we have, I'm going to do 2 of them. So which 2 do you want me to do? I'm going to do 7 and 1 more. 8, okay, that's same 2 questions my first period asked for. So number 7, I give you the volume, and we want to figure out the scale factor and the surface area ratio. So let's go ahead and reduce these. What can I divide 162 and 384 by? What did you say? What can I reduce it by? I can reduce it multiple times. I can divide by 2. I get 81 and 192. Is there another number that I can reduce it by? Do you want to hear a hint? Okay, so I see that I can't divide it by 2 again. But if you add the digits, so 8 plus 1, you get what number? 9 is divisible by 3. Okay? 1 plus 9 plus 2 is 12 divisible by 3. If the digits are divisible by 3, then the number is divisible by 3. How cool is that? You never knew that? I learned it, I don't remember when, but ever since then, it's like my easiest hack. It's like one of those hacks that I just normally do. So I look, is the number even? Typically, I just divide by small numbers if it's a large number and I don't want to play that game. So I'll divide it by 2, and then I'll divide it by 3 if I notice that every digit is, when you add them together, the sum of the digits is divisible by 3, then the number itself is divisible by 3. I don't know if I learned it in college or what. 81 divided by 3 is 27, and 192 divided by 3 is 64. That's a lot more manageable. I don't think that will divide further. I might be wrong. Because, yeah, 27 is divisible by 3 and 9. 64 is divisible by 8. Neither of those are common. So I think we're done. That's volume. I know 27 is a cube, and I'm guessing 64 is a cube. So here's how you find out. Depends on which calculator you have. Okay? So if you have a calculator like mine, you're going to hit this number. So you're going to hit second, and you see this. This is your caret button, how it goes answer up. That's how you raise a number to the third power, okay? So if we had 4 and we raised it to the third, that's what we would get. Oh, guess what? That's 4 to the third. So to get the third root, you're going to press 3, and then second that button again, the caret button again, where it says X root. That takes the third root, or the cube root of a number, okay? If you have this calculator, you cube root by pressing 3, second the caret, the arrow up button, okay? That's how you take the cube root. If you have this button, to raise a number to the third power, so 4 to the third, you press this one, where it says y to the x, okay? That's the y to the x button. You're taking 4 to the third, you get 64. To go backwards, you press the same thing. So you press the root that you're trying to take of. So we're trying to take a root of, I'm saying that wrong. You're trying to find out the cube root of this number, okay? So 64, then you press second, this button, and then you take the root that you're looking for. You're looking for the third root. You get 4. Okay? Yeah, are you sure? Or you can just memorize your cubes. It's the same thing as this one. Find the arrow up. Haley. You found it? Okay, I'll show you on this one. The arrow up button is right here. You have to press 3 first, and then press the arrow up, where it looks like that, and then you press 64. 4. You got it? Okay, cool. Showed you with all 3 types. If you have a Casio, I'm so sorry, I cannot help you. Cube root of these numbers. What's the cube root of 27? Cube root of 27. 3. Cube root of 64. And then square those numbers. We get surface area ratios. Good morning. 9 to 16. Very nice. Okay. What about for 8? What are we given for 8? The squared. Okay. So we got to reduce them. What do you want to reduce by? Ooh, 15. Let's do it. I get 64, and 375 divided by 15, I get 25. Very nice. So that's my surface area ratio. That's the squared version. We can just take the square root and get the scale factor. What's the square root of 64? 8. What's the square root of 25? 5. And then to go down here, we're going to do what? What do we do with 8 and 5? Nope, cube it. Cube root is when we're going backwards. So 8 times 8 times 8. What do you get, John?
8 times 8 times 8.
Mm-hmm.
The big number, 217 or something.
Where's your calculator?
I was trying to do it off the dome. 512.
5 times 5 times 5. 5 cubed. 125. Very nice. And since my scale factor is reduced at 64 and 25, we don't have to worry about reducing it any further. We got it. Questions on this?